Well, in this question, it says early childhood development studies indicate that the more often a child is read to from birth, the earlier the child begins to read. A local parents group wants to test this, and so the group samples families with young children. So basically, you might have heard that before, that you should read to your children when they're young, even when they're in the womb. Lots of talking, lots of reading, and even when they're little babies, even though they can't answer back, if you read to them a lot, that'll help them. Well, is that really true? Is there data supporting that, or is that just what people are saying? How do you test these ideas? This is important. This would be a medical test, right? Very important medical or maybe psychological, educational, whatever you want to call it. It's an important thing for how society and if you're going to be a parent, how you parent. Is this true or is this not? Is there statistical evidence behind it, or is it just people saying stuff? Well, so they did a study. This study's a little confusing. Let me show you. So basically, these 52 kiddos, they were read to at least 3 times per week. So this is what the parents read often to them. And over here, this is parents read less often, right? See, it's fewer than 3 times per week. And this one's more often, at least 3 times per week, right? And then on the side, you have what happened with the kiddos. Did they started reading before age 4? So that the kid became an early reader. Or the bottom, started reading after age 4. The kid was a late reader. I don't know if that's late. I think I've had some kids that didn't read till they were 6. I don't know. Anyway, that's where it says the kids are late readers here. Kids are early readers there. So let's try to be clear then. So with these 52 kids, what happened? Their parents read to them more often, and they indeed became an early reader. These 34, their parents read to them more often, but nevertheless, they became a late reader. I think that's what happened with at least one of my children. So then how about up here? The parents read less often. Nevertheless, these 35 kiddos became early readers. And then with these 52, the parents read less often, and the kids learned to read a little bit later after age 4. Okay, so is this statistical evidence, strong, weak, showing that reading to your kids, more often helps them to learn to read themselves earlier instead of later? Does that have an effect? Does parents reading more often to their kiddos make them become an early reader more often than a late reader? Or does it have no effect, or what? All right, so how are we going to do this? It says create a 95% confidence interval to estimate the true. Remember, we're always going for what's true. We have these kiddos that we surveyed, but what we're always interested in all these kind of questions, what's really the truth for all families forever who will read to their kids or not read to their kids very often? What's the real truth for everybody forever? That's what we mean by the true difference. And we're going to try to figure it out based upon our little sample. We're not going to be 100% sure, but we want to be 95% sure about what the truth may be. So, all right. So basically, so it says right here, notice it says, if you keep reading, between the proportion, it even says the word proportion. So we know we're going to go on the calculator to the 2 proportions. 2 proportions. Calculator. Well, here, maybe I better not write that there. I'm going to probably interfere with things. Let me bring down here. It's 2 proportions. So we're going to go to the online calculator. How am I getting that? How do I know that? Well, if you come back up here, way up here, here's the unit 4 notes. Here's 2 proportions. Go to the online calculator, 2 proportions. So that's where I'm going. Because we're talking about 2 proportions here. It says the word proportions. We're talking about, what part of the kiddos read early, what part didn't. That's always proportions. Okay, so when you go to the 2 proportions calculator, it's going to ask you for the sample size and the number of successes. So we get that clear. And it's going to say for the first group and for the second group. Okay. And so what are those going to be? Well, first off, what is the first group and the second group? What are the two groups we're trying to compare? What are we trying to compare? You got to be clear on the meaning of these words and what it is we're actually trying to compare here. What are we trying to compare? Well, we're trying to compare the first group's is parents read more often. And the second group is parents read less often. Let me check that S a little better there. Less often. So that's what we're comparing. So we're going to have four numbers. What is the sample size for the first group? The one, how many kiddos did we sample where the parents read more often? Well, parents read more often. It's going to be these two added up. Here, let me do that with the red. Add those up. That's going to be, what's that? 86. So 86. So 86 kiddos had parents who read to them more often, right? These 52 who became early readers and these 34 who did not become early readers, they all had parents reading to them more often. So that's the sample size. How many were successful? Well, that's the 52. That's the number that are successful. 52. So 52 were successful in producing an early reader, right? So out of these 86 kiddos who had parents who read to them more often, 52 successfully became early readers themselves. The other 34 did not. That's number success. Success here is becoming the kid becomes an early reader. And then I'm going to add up these other ones here as well. It's going to be 87. So out of the 87 in the second group, where the parents read to them less often, nevertheless, 35 were still successful in becoming early readers, weren't they? Most of them were not, though. It looks like it does make a difference. 35 became early readers out of the 87. That's how much success they had. So we're going to put those into the online calculator. You also got to put in the confidence level. So what is our confidence level? They say 95% right there. So that's always a decimal, 0.95. And you keep the radio button on not pooled. Where am I getting all this? That's I'll show you up here in the online calculator thing. Come up here and it says for two proportions, you jump down here for confidence intervals. Fill in CL as a decimal, confidence level as decimal. Leave the radio button on not pooled. Okay. So we're going to do that right down here. So there's our numbers. Let's go to the online calculator. Let's go to the online calculator. Number 19, two proportions. Click on that. Number 19, two proportions. It opens up. And there it is. And so I'm going to go back to the thing and I'm going to go, okay, what are the numbers here? I'm looking right here. 52, 80, or here, I'll just go 86, 87. Let's do it that way. 86, 87. So bottom one, 87. Then up here, on the right side, 52, 35. Okay. Now, confidence level is 0.95. And the radio button, I just leave it here. I'll just leave it on not pooled. Calculate. So what I care about, I don't care about the Z and the P. I'm not doing a hypothesis. I care about the lower bound, upper bound. There they are. 0.05, 0.348. That's what we take back. Again, how did I do that? There's the numbers. I choose the put in the confidence level not pooled. So, and sure enough, there is the same answer we saw right here. Here's the constant, put parentheses around it and a comma in the middle. There's the 056 and the 348. Okay. Now the final question is, according to your confidence interval, like, what does that mean? See the answer right here. What is the real life meaning? How do we know this is the real life meaning? Basically, the differences between these statements, let me try to make this clear for you, is lower, higher, or inconclusive. Basically, is the first group lower, higher, or is it inconclusive? How do we know? Well, let me show you in the notes where to get the answer, and then I'll try to reason with you logically as well. So in the notes where we get the answer, if we come in here, here it is. I'm in the Unit 4 notes, jumping down to number 4, the meaning of a confidence interval for mu1 minus mu2, subtracting two groups. There's three options. Either you got two negatives in your confidence interval, and then if you jump to the end of the line, that means first group is lower than the second group. Or you got two positives, jump to the end of the line. That means first group is greater than the second group. Or you got some negative, one positive, which is basically no confidence, could be different, could be the same, inconclusive. There's your three options. So what did we get? Let's go back to our question. We got, let me just write it up here to be clear, 0.056, 0.348. We got positive, positive. They're both positive numbers. What does that mean? Well, let's go back up here. What is positive, positive, all positive? Jump to the very end. Mu1's greater than mu2. There's our conclusion. The first group is greater than the second. So we conclude mu1, or in our case, it's P1 actually. P1 is greater than P2. What is P1? What are we talking about? What's P1 and come back down here? What's P1 and P2? Remember, it said it right here. The first group is parents who read more often. So this is parents read more often. And the P2 right here, second group, parents read less often. That's read less often. Okay. And we're saying greater. That's what our confidence interval means. When you get two positive answers in your confidence interval, that means the first group is greater than the second group, meaning the parents who read more often to their children have greater success than the parents who read less often. There is strong statistical evidence. In this case, the data strongly tells us we're 95% sure, right? It's going to be the higher one, right? See it right here. This means higher, right? Greater. When you're on the wide side, you're bigger. P1's greater than P2. So it's going to be this option right here. With 95% confidence, the proportion of children who start reading by age 4 is between this and this, higher among children who are read to frequently than those who are read to less often. Now, that's how you get the answer. Now, let me show you why. You might think, why? If I was you, I'd be thinking, why does two positive numbers in my confidence interval mean higher? And why would that be? Well, it's because remember what we're doing here. Remember what we're testing. This is where it's a little tricky. You got to remember, we're testing P1 minus P2. Right here, it says, compared to those who read P1 minus P2. So we're comparing. So just you have to think logically. If I told you, hey, I'm subtracting, I'm taking P1 minus P2. If I told you, hey, I subtracted two numbers, like 10 minus 7, comes out positive 3, then the first is bigger, right? If you subtract two numbers and you get a positive answer, the first is bigger. Whereas if you subtract two numbers, like 7 minus 10, and you get a negative answer, and this one's positive, then that means the first number is smaller, isn't it? First number is less, whereas here's the first number is bigger, greater. Right? You with me? If I said, hey, I subtracted two numbers, I got a positive answer, that means the first number is bigger. If I subtract two numbers and get a negative answer, that means the first number is actually smaller than the second. Okay, so what? Well, we are 95% sure that the real difference between P1 and P2, when I say real, remember, we're trying to figure out what's true for all parents forever who will read more often or less often to their children. What real difference does it make for all? Based on this little data, we're 95% sure that at the end of time, after all families that have read more or less often to their children, that the real truth will be somewhere. We're 95% sure that the real truth will be somewhere between 0.5 and 0.348. What does that mean? Well, just put that on a number line for a second, and you'll make sense out of it. If I have a number line, zero's here. It's a funny zero, huh? And right here is that 0.056 number, and out here is the whatever it is, 0.348. Those are our two numbers in our confidence interval. So we're saying we're 95% confident that the real difference is somewhere between 0.5 and 0.3. They're both positive. If it's between those two, it's got to be positive. We're saying we're 95% sure that the real difference for all parents for all time, if somehow we could know that at the end of time, is the real difference will be somewhere between 0.5 and 0.348, meaning it'll be a positive difference. If you subtract two things and get a positive answer, that means that first number was bigger. So we're 95% sure that that first number is bigger, that parents who read to more often really do have higher success in helping their children be early readers. That's what we're saying. So there we go.